However, in early days, before we knew well, we still know everything, before we knew a lot of what we know now, okay, this is what people thought it was, that it was blue. But every bit of it's red, which is kind of cool. Busted another myth, right? Just call me the myth buster A&P teacher.
So when you cut yourself, for instance, and the blood is red and it comes out, and after a while it gets dark, is that because the oxygen has done something with the atmosphere?
Yes.
And then
It's clotting. It's clotting. The clotting factors have moved in. It's trying to stop the bleeding, and therefore it's trying to arrest at that point the blood, and basically the blood's drying up. So those blood cells that you're seeing, those blood cells are just simply drying up and they'll die.
So when someone has cyanosis, what that?
The cyanosis is, once again, we've got the blood flow, but something else is wrong. Okay, something's wrong with the respiratory and picking up of the oxygen and the oxygen making it to the tissues. So once again, we're at the cellular level. So at that cellular level, they're not getting a drop off of the oxygen at the tissues. The tissues are now getting deprived of their oxygen. They're starting to let you know, hey, we're gonna die here if you don't get us some oxygen. And they turn the color that they turn, because they just don't have the blood flow. Make sense so far? Any questions? Okay. So when we begin to look, like I said earlier, the values for red blood cell count and hemoglobin, they're going to be lower in women than they are men, because men have more androgens for one thing, and androgens help to stimulate red blood cell production. We also lose the blood through menstruation, and then the hematocrit is inversely proportional to the percent of body fat. Inversely proportional means what?
Reciprocal.
Opposite? And who do they say has more body fat?
So it's what?
So hemoglobin's going to be, we have more fat, so hemoglobin's lower. Men have less fat, so hemoglobin's higher. They get to lose weight faster and everything. Just saying. So, let's take a peek for this red blood cell. What I mean by the production from the stem cell. Because we're going to see this with the white blood cell also. Okay? So the red blood cell production. Over here, my pluripotent stem cell, and it's just that one. But this one gets to branch out in many different ways. Okay? So, we need to produce how many red blood cells per day? Was it 2 to 400 billion? 200, 400 billion? Okay. Because we destroy almost 2.5 million of these red blood cells every second. So number one, we have to replace them. And then number two, we've got to break down that red blood cell that's being destroyed. So the production, erythropoiesis, okay? We lose a whole bunch of them. We got to make a whole bunch of them. The average lifespan is about 120 days. The development takes about 3 to 5 days. So after this point, the red blood cell is considered mature, and it goes on to start supplying the tissues of the body. As it develops, it will reduce in the cell size. We'll get an increase in cell number as more get produced. It worries about the synthesis of the hemoglobin, and then we got to make sure we lose the organelles. So in this production, the pluripotent stem cell, when stimulated by a chemical, the pluripotent stem cell, when stimulated by a chemical, will form colony-forming units. So if this stem cell is stimulated by a chemical that says the body needs more red blood cells, it will pinch off, it'll produce a red blood cell colony forming unit. Is everybody following me? Okay? Now, that first committed cell, the colony forming unit, it is going to have receptors for something called erythropoietin, known as EPO, and it comes from the kidneys. Why in the world would the kidneys be involved in red blood cell production?
Filtering process?
Hmm?
The filtering?
When the blood leaves the heart by way of the aorta and goes through the aortic arch and begins its descent from descending aorta, the first organs that it's going to hit is the kidneys. Meaning, the kidneys can detect levels in the blood, and therefore, if oxygen levels are off, they can produce the hormone erythropoietin. Why would oxygen levels be low that could be picked up by the kidneys?
If they have COPD, if they have some sort of chronic.
You're thinking too much. Let's go back to our cellular level. If the first place that the blood leaving the heart is going to hit is the kidneys, and if the kidneys can detect low oxygen levels, what does that tell me about the red blood cell count? The red blood cell count is low. So if my red blood cell count is low based on the oxygen levels picked up at the kidneys secrete the hormone erythropoietin. The receptors for the hormone erythropoietin are found on my colony forming unit. So if the colony forming unit has the receptors for the erythropoietin, that's going to say make more red blood cells. To do that, it will begin to make more red blood cells. But here's the thing. When the CFU gets stimulated, the first thing that gets created are precursor cells. So the first cell to get formed is an erythroblast. Oh my stars. Where have I heard blast before? Bones. My osteoblast, my fibroblast, my chondroblast. Are you following me? So the first thing that's going to come from the colony forming unit is a blast cell. The blast cell, is that the mature form?
No.
It's immature. So this erythroblast is immature, and it needs to mature into our red blood cell. But on the pathway to becoming the mature, the erythrocyte, that cell has to mature. Meaning it needs some time to produce the hemoglobin, spit the stuff out, and start its job to become the mature cell. So in between the blast and the erythrocyte, in the midterm of the life cycle, it is a reticulocyte. It is at the reticulocyte that we're going to have the maturation occur. We're going to get to make our protein. We're going to get to spit the stuff out. Once we spit the stuff out, it will now be considered the mature cell, the erythrocyte. At the point, did everybody follow me on that one? At the point that that colony forming unit with that stem cell to the erythroblast, we are in the bone marrow. When it becomes a reticulocyte, it has now entered blood circulation. And it will spend a day or two in blood circulation finishing the maturation process to turn into the mature red blood cell.
The reticulocytes in the bloodstream?
Yes, at the point it becomes the reticulocyte, it has entered the bloodstream, the circulation, and within a day or two, it turns into the mature red blood cell. Yes, no, maybe.